Here is the program on printing the right diagonal of a 2D array in a square matrix form. That means number of rows and number of columns are equal. So this time also we are taking n number of rows and n number of columns. Okay. Now filling it with random numbers. That's also same as the previous, like random number is greater than 0 and less than 1. With that fraction, if I multiply 100, I will get a 2-digit number. I'll take the integer part of it and I can fill this with a 2-digit number. I can even show you if I fill it with if I multiply it with 1000, then I will get a 3-digit number. Just do this part of maths yourself and you will find it satisfactory. Then comes the printing. Printing part is also okay, just to print with the gap of a tab, just to space them out. And then comes printing of the right diagonal. Now, this right diagonal is those numbers which are beginning with the right top and are ending at left bottom of the diagonal like that. This is the first element of the right diagonal. Then this one. So notice what the loop structure will be like. For row number 0, the column value is not same as R, but is the last of the column value. That means if n is the number, like the number, then n minus 1 will be the position of it. 0 to n minus 1, that's why. So this is the first value of C against R as 0. Then when R goes up, R becomes 1 more. Then this becomes 1 less than the previous. Therefore, look here, as the loop increases 1 by 1, notice that C is decreasing 1 by 1 inside the loop. So with each increment in R, C is decreasing by 1. Okay. So with this, I can say that C begins with the last or the highest value, and 1 by 1 with each movement of R, parallelly C is also moving in the downwards. R is moving upwards, C is moving downwards. I can also make this like Java modification of putting C is equal to n minus 1 here. This is something that Java permits. So what will I do is I will make this a comment so that you can understand that this change I had brought. The condition stays the same as R is less than n, and in parallel to this R plus plus, I will put C minus minus here. This is just a style statement. If you have any difficulty, you may skip this part happily. Only if you are fond of doing a little bit of stylish things, you can keep this in your syntax mode. And with this, I will come to the code execution once again, and I will show you how I can print the right diagonal elements with another set of elements with another order of the array. This time I wish to say take 7 as the number of rows and columns. Just check it out. Is it satisfying you? Okay.